We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the U.S. every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40 and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
Check this out. There's a giant tornado heading towards you, and it's so fast. These twisters can move at crazy speeds of more than 250 miles per hour. Plus, they can carve a pathway 50 miles long and a mile wide. Sometimes you can see them coming clearly, while in some cases, low-hanging clouds or rain can hide them, so they sneak up on you and you don't even see them. And in most cases, a tornado can develop so fast that no one can even warn you in time if it's already too close. And now, this insane storm is really close. Maybe you have a couple of minutes to get somewhere safe. Do you have a basement? Go hide. Or maybe, I know this is a crazy idea, but what do you think about going inside a tornado to check what it would be like? Now, some tornadoes appear as rope-like swirls, while others have wide clouds in the shape of a funnel. And here's the second one, right before you. Look at these whirling winds born in a thunderstorm. They extend down from it to the ground. Many times, hail joins the party too. The U.S. itself has something like 1,000 tornadoes per year. Texas holds the record with about 120 tornadoes per year, a record not to be proud of. But you'll generally see most twisters in Tornado Alley, which is a stretch of land in the midwestern part of the U.S. They develop when warm, moist air coming from Mexico meets cool, dry air from Canada. These two clash and turn into a powerful storm that at some point can spawn tornadoes. And you'll see most tornadoes there between April and June, though lately some have come even in December. They can range from a regular dust storm to an incredibly powerful force that can carry away cars, large trees, and even houses. But this is a unique chance. You've never been this close, right? Plus, it's a gigantic one. You don't often get to see such a big one. Okay, ready then? It's getting closer. You feel the wind getting stronger while tossing dirt and debris in your face. You close your eyes and whoosh! You're inside, and it's crazy. Vicious winds are hurling and spinning you around. They're lifting you up at the same time. Feeling dizzy? Feeling like Dorothy from The Wizard of Oz? Now may be a good time to check what's really happening to you, while inside swirling with winds and… Oh wait! Is that your neighbor's motorcycle spinning together with you? Hope it'll stay that far away. Now, let's take a moment to catch up. Being in the middle of a raging tornado is actually something you might survive. But I won't lie to you, it won't be easy. The first thing you'd sense would likely be the temperature changes. Inside this crazy twister, it can be 36 degrees colder than outside of it. That's because the center of the tornado funnel spins all the time. All that funneling makes the inside of the vortex way colder, and it makes the air way thinner than you used to. The air would be 20% less dense than, for example, what you would find at high altitudes. Now, I hope you're not planning to stay there for too long. Disclaimer here, the atmospheric pressure inside this swirling vortex is so low that your lungs won't be able to extract enough oxygen. Now, to give you a perspective of all this, breathing inside a tornado is like trying to get some air at an altitude of 26,000 feet. That's a pro level, similar to climbing Everest. So yeah, you'll need some help just to be able to take a regular breath. In short, you'll probably pass out after only a couple of minutes. But don't worry, I brought you this special mask, so breathing is not a problem anymore. Hey, did you notice how smooth the airflow from the inside is? Some storm watchers ended up inside a tornado. Later, they said it all looked so chaotic with all those raging clouds and wind swirling around. But from the inside, the air is surprisingly smooth. But that doesn't mean you'll get a peaceful ride because of it. And it's not a solo party in that thing. The neighbor's motorcycle is not the only thing you'll see there. Wood, bricks, glass, maybe even cars, cows, motorhomes, bricks, roofs, and other big objects. You'd be pretty lucky if nothing crashes into you in all that chaos. With all that debris that's swirling at, for instance, 310 miles per hour, you can hardly avoid it. But let's just say a miracle happens and you got through it. Now you're really dizzy, and you're just wondering when all of this is going to be over and if you're even going to be able to come out of this gigantic tornado. Well, the tornado will eventually slow down. It happens because cool air enters the twister. Just because things are settling down, it doesn't mean you can relax. Well, your stomach can, since all that crazy swirling is done, but the tornado will drop you from whatever height you're on when it stops. If you're somewhere in the countryside, there might be some soft bale of hay to break your fall. Oh wait, we're talking about a twister that's probably more than 45,000 feet tall, so that won't work. I hope you brought your parachute, because now would be a good time to pop it. Nope. Hey, don't worry, I'm all about happy endings, so I'll help you out. Here you go. And now you're slowing down, enjoying the view, if you even see anything around you from all that dizziness. How come there are clear sunlit skies from your left, you may wonder? It's not unusual. Tornadoes often form near the edge of a thunderstorm. It's like a border between two different worlds. And it wasn't even windy. Plus the air was very still before it hit, right? Well, that's common too. Okay, I think you know this kind of scenario is impossible in reality. So it would be best to find a safe spot quickly if a tornado is close by. Use your underground shelter first. And if you don't have one, your basement could be the next best choice. Prepare ahead of time with a battery-operated TV or radio, together with fresh batteries, or a device with internet to be able to hear the latest updates on the tornado. Include some non-perishable food, water, and other essentials prepared too. As it turns out, some people really were picked up by tornadoes, and they managed to go through it. A tornado actually dropped them a few hundred feet away without a scratch. Hey, I'd say that's a whole lot of bother just to save some bucks on Uber. But you can't have a guarantee you'll be safe or where you'll end up. It would be incredibly hard to get out of one of those big and fierce ones, though, like supercells. They fall into the category of the strongest type of storms, mostly thunderstorms. And imagine falling into waterspouts. Those could be fine, though, at least the beginning, because they're weak and they form over warm water. So they could be like a part of your spa day, at least until they move inland and turn into a real tornado. Now, dust devils wouldn't be that pleasant. They're not that big, but we're talking about columns of air that rotate at large speeds. And you can easily see them because of all that dirt and dust they pick up, which is why you need glasses for that. Whoops, wait, I forgot that, so I can't help you this time. But if it makes you feel any better, they're not associated with thunderstorms. Don't know why that would make anyone feel better when I think about it. But if you're willing to jump into a fire tornado, I'll find you a special suit that will keep you safe while spinning through smoke, gas, and flames. I promise. Columns here are narrow and they rise vertically into the air, similar to a dust devil. Of course, the heat is crazy. And as updrafts are becoming stronger, and if there's enough dry fuel, a fire whirl is turning into a real fire tornado that extends from the ground up to the cloud, moving incredibly fast. Okay, let's stop now. I'm pretty dizzy.
Ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat. As you peer through the window at the sudden chaos outside, you're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth. You always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water, it's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, the crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over half an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy, the Sahara. Nope, it's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
The air is bone dry and the wind is out of control. You feel like you're standing in front of a fireplace, but you're not. You're standing in your backyard about to grill up a feast when you suddenly see the trees shaking uncontrollably. Leaves are falling like confetti. The wind just blew your last piece of laundry into the great unknown. You look around and everyone else is just as confused and scared as you are. In the distance, you see a red horizon of fire in the forest and a large vortex touching the sky. You drop everything and make a break for it. You'll be lucky to outrun a tornado. They usually move at around 30 miles per hour, but can reach up to 70. Imagine running away from a giant twister, hurtling towards you at Usain Bolt speed. The roads are crowded with people trying to find shelter or just get out of town. You get in your car and try to start it, but the wind knocks a sign over. It smashes your windshield. Anyway, a big tornado is powerful enough to swing your entire car around. You gotta go on foot. Best bet? Head for your buddy's house. They have a deep basement stocked with supplies. Whenever a tornado flies on by, try to take cover somewhere underground. If you don't have a basement, avoid any windows and try to stay underneath something sturdy to protect yourself. You're running to your friend's place. Everything around you is getting swept up by the insane winds. But when you turn around, you see the tornado turning reddish. You can barely see it because of the debris, but the spinning vortex, it's on fire. It's a fire tornado. These spinning flame winds can reach 140 miles per hour and can be between 15 to 150 feet tall and as much as 500 feet wide. These monsters occur when tons of smoke get whirled around, so the thunderstorm starts to act like a tornado. By the way, many fire tornadoes can even occur in a bonfire and are called fire whirls. Next time you're camping or setting up your living room fireplace, check it out. You might just spot one spinning around in there. Anyway, it's getting closer and closer, throwing ash all over. It's already pretty hard for you to see where you're going. You use your hands to wave off some of the smoke and ash flying around your face, but it's useless. You keep sprinting as fast as you can until you spot a huge truck. Just park right there in the middle of the road. You crawl underneath. It's one of those trucks that has like 20 wheels. They look so big and heavy up close. Then you hear a creaking sound and a humming sound. The wheels, they look magical. Gracefully, they start lifting off the ground, as if the truck's part of some Vegas magic act. As the tornado gets closer, the wheels rise higher. Better to be far away from here when the truck smashes back down to earth. You crawl out and keep running. You find a convenience store to take cover in, making sure not to stand too close to the glass. You head as far into the store as you can, ready to wait this thing out. But all around you, the land is burning. This fiery twister is a monster, and it's charging towards you. You look out in the distance and see another fire tornado wrecking another part of the city. In order for a tornado to form, it needs open space. That's why many of the tornadoes you see on the news happen in the same part of the U.S., where there aren't many mountains and it's nice and flat. But of course, they can happen anywhere. It's not normal to see tornadoes in the bustling downtowns of America's biggest cities. They need a lot of open space for the rotating vortex to happen. But today is not a normal day. A tornado forms in a supercell thunderstorm. That's when you have two different air temperatures going at it. The vortex you see in tornadoes forms when warm air and moisture come in from above. Below, it's a mess. The end result, the huge spiral funnel cloud we see in every tornado movie. Meteorologists can predict tornadoes somewhat by monitoring the amount of moisture in the air. Every second counts, so keep the TV on next time there's a storm brewing near you. But this doesn't really apply for a fire tornado. The winds are getting stronger and you're feeling the heat even inside the store. Outside, spiraling flamethrowers are torching everything in their path. It may be too late to find an underground shelter. You improvise a way to help protect yourself by hiding underneath the cash register. And now, you can't see anything. There's ash everywhere and the windows are all smashed, thanks tornado. Ash is one of the most dangerous parts of a fire tornado, unless you're not really into breathing or seeing. Your best bet would be to stay as low as you can to the ground. Since smoke rises, there might still be just enough oxygen down there. Crawling your way along will prevent you from getting struck by any flying objects or debris. The fires are now spreading, and there's a lot more smoke. The trees outside have caught fire, and there are glowing embers as far as the eye can see. These embers can travel more than a mile and can start fires on their own. Now that it's really going crazy, stuff in the store starts flying about, like the smoke wasn't bad enough. You feel like you're inside a snack-filled erupting volcano. It's only a matter of time before the table you're hiding under will get pulled up into the air. The sound inside the store is intense, like sitting next to a jet engine. You can't tell if you're sweating from the heat or from adrenaline. But suddenly, you see someone at the other end of the store waving at you, trying to tell you something. They have an underground storage room. You're saved. But getting there is going to be a real problem. You see, the table screw's getting loose, getting ready to fly into the air. You find a bottle of water next to you and rip a piece of cloth from your shirt. By using a wet cloth, you're able to filter out some of the nasty stuff in the air to help you keep breathing. So you crawl your way out from underneath the table and make your way to the underground storage room. But the ground is covered with broken glass, and there are cans and stuff everywhere. Even the cans are starting to heat up. You crawl like a sloth, trying to avoid anything pointy. The fire tornado is still out there, and it's getting even closer. You finally make it, and the clerk pulls you down the stairs. It's dark, but there's a single battery-powered lamp to help you see. When it comes to fire tornadoes, it's best to just wait it out. Most of these firestorms don't last that long. So you relax, or try to, and wash your face in a nearby sink. You wipe off all the black ash from your face and breathe normally again. But as you get a bit more relaxed, you feel the ground shaking. Everything around you starts to fall. You and the clerk duck behind a pile of canned goods. Then the tornado takes it up a notch. The store above you gets lifted up off the ground. The only things left, steel and concrete foundations and a couple of random columns. The steel door that's separating you from the outside is barely holding it together. You can see the screws getting loose. You can actually see fire enter the storage room. Everything in the room gets toppled over in an instant. The wind is even louder than before. But then, it's over. Those few minutes felt like hours. You and the clerk climb out and see, well, not much to be honest. The convenience store looks like it got ripped off like a Band-Aid. And all around you, a town you can't even recognize anymore. The big problem with these fire tornadoes is the fires they leave behind. They can ruin towns, forests, farms, and lives.
It was June 1928 when Mr. Keller almost lost his life in a terrifying natural disaster. He was outside with his family when he noticed an umbrella-shaped cloud that seemed to be approaching them. It gave him a sense of foreboding. A tornado was probably forming there. Indeed, in no time, 3 huge funnel clouds were dashing their way. After rushing his family into the storm cellar, Keller decided to have another look, and what he saw both terrified and mesmerized him. The twister was directly overhead, but inside the swirling cloud, everything was eerily still. The man could feel a strong, grassy smell. He had trouble breathing. He looked up and saw a circular opening right overhead. It was around 50 to 100 feet across and around half a mile high. Keller could clearly see the walls of the rotating cloud. Constant bursts of lightning zigzagged from side to side non-stop, illuminating this horror movie scene. The man could also see many smaller tornadoes forming and breaking free. A deafening, hissing noise was overwhelming. And the next moment, the tornado skipped over Keller's house and smashed the home of his neighbors. Mr. Keller wasn't the only person to see the tornado from the inside and live to tell the tale. But other survivors didn't end up as unscathed. It seemed to be a regular day when Chris Tuving from Dallas, Texas got to the Little Caesars in 2019. They had run out of pizzas, so he decided to wait. Well, it was a grave mistake. A powerful tornado hit the shopping mall where he was staying and pulled him out of the building. Chris managed to find a support column and held on for dear life. but no muscle strength could compare to the terrifying power of the tornado. Tavang was lifted into the air and thrown into a truck parked in front of the restaurant. He tried to hold on to the hood, but there was nothing to grab. In the end, he managed to hold on to the rim of the left front tire and stay there until the whole nightmare stopped. The tornado Chris survived had sustained winds of 140 miles per hour and was 13 football fields wide at the base. Eric Simmons recalled taking cover from a tornado in May 2019 by climbing into his truck. Once inside, he looked out of his right windshield and saw vines growing along the fence. They were moving around in a bizarre way that confused the man. And then it all started. Suddenly, everything Eric could see was wind and pitch-black darkness. Then, a section of a roof flew over him and shredded apart mid-air. The truck's back windshield shattered, showering the man with shards of glass. A tree in front of him was lifted into the air like a twig, and the fence blew over the top of the truck. Simmons could feel the back of the vehicle lifting. He could see the power lines exploding right in front of his eyes. Even though the visibility was terrible, he could still see the flashes. It all lasted around 45 seconds, but to him, an eternity seemed to have passed. When the coast grew clear, Eric got out of the car, but he could barely walk after the shock he had lived through. He couldn't speak. It was one of the most horrifying and traumatic experiences of his life. According to the man, the real reason why he was so terrified was because he had no training, no warning, and no defense against whatever was coming. Later, he found out that the tornado had almost taken his life at a speed of 86 to 110 miles per hour and was around 75 to 100 yards across. A tornado is a rotating column of air that touches the ground. Sometimes it's connected to the base of a thunderstorm. The wind speeds inside tornadoes can top hundreds of miles an hour. No wonder they have enormously devastating potential, picking up objects, unrooting trees, destroying buildings, you name it. The problem with escaping a tornado is that it's not always easy to see. The wind, however severe it is invisible. The first sign of an approaching tornado might be the infamous rumble resembling the noise a moving freight train produces. There are also some other sounds indicating that a tornado is coming, but the human ear can't perceive those. When you spot that classic tornado cone, it means it has already developed a condensation funnel made of water, dust, and debris. The most destructive tornadoes are born from rotating thunderstorms, called supercells. Luckily, those are something meteorologists can actually notice because such storms have a well-defined appearance on radars. Experts believe that the difference in the temperature of such a storm can determine how likely a tornado is to form. And still, there's a lot we don't know about this process. For example, the question about why and where tornadoes are most likely to appear remains unanswered. The strength of tornadoes is measured with the enhanced Fujita scale. The rating goes from 0 to 5, considering the damage caused by a tornado and its wind speeds, where EF0 is the weakest tornado and EF5 is a tornado I hope you will never ever come across. The EF scale rounds off at wind speeds of 318 miles per hour, with strong frame houses being lifted off foundations and carried long distances to be eventually broken into pieces. Cars fly through the air for more than 328 feet away, and steel-reinforced structures are left badly damaged. Despite this terrifying power and ferocity of tornadoes, authorities report that even the worst of them have a 99% survival rate. But it doesn't mean that you shouldn't take all possible precautions to avoid ending up inside one. Stay away from doors and windows. Move to an interior room if possible, and use pillows, blankets, and mattresses to protect yourself from flying debris. If stranded outside during a tornado, crawl into a ditch and cover yourself, protecting the head. Now there's another twister that is as scary as a tornado, but this one forms in the water. Whirlpools appear when fast-flowing water crashes into an obstacle or another current. The water starts swirling in a downward spiral. creating a vortex that can pull objects, animals, and even small boats that happen to be nearby to the bottom. One more way for a whirlpool to form is the sudden appearance of a sinkhole created by a collapsed cave, for example. This makes water flood the hollow structure and creates a whirlpool similar to the one you see when you pull the plug out of a bath filled with water. While some whirlpools are small and brief, others can reach enormous sizes and be driven by constant currents. The most dangerous of them are maelstroms. If you get into a whirlpool like that, your chances to get back to the surface are slim. The incessant movement of the water and its pulling power can leave you disoriented and stuck without air. That's what happened to Stuart Foulstone when he got trapped in a whirlpool. His first instinct was to swim out of it, but this idea proved to be hopeless. The footage filmed by the cameraman attached to his helmet later showed that the man had been underwater for almost 3.5 minutes. He had probably been dragged all the way down to the riverbed. There, the pull of the twister lessened a bit and finally released its hold. The guy was lucky to get spotted face down in the water and pulled to the surface by a kayaker. The depth a whirlpool can pull you down to can vary. It depends on its power and size. Sadly, not everyone who got trapped in a whirlpool survived and got out again. In different ways in which whirlpools form means that sometimes they can appear out of the blue. You can't predict this process and get no warning. So the best way to stay safe is to wear your life jacket at all times when in the water. If you get pulled into a whirlpool, try not to move in the same direction as the water flow. Aim for the outer edge rather than the center of the twister. If you're lucky, the whirlpool might throw you back up. There have been precedents. And if you come over a whirlpool in a boat or kayak, do your best to stop the boat from filling with water.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, Do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean's surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So, there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.